Welcome to G Fun Facts Online, where we dig deep into the science that shapes our world. What if I told you that thousands of kilometers beneath your feet, there's a river? Not a river of water, but a slow-motion river of solid rock, flowing in a process so powerful it moves entire continents and builds mountains. It sounds impossible, right? In our world, solid means stable, unmoving. But deep inside the Earth, the rules are completely different. For decades, scientists have known about a process called mantle convection. Think of it like a giant pot of water boiling on the stove. The Earth's mantle, a nearly 3,000-kilometer thick layer of rock, is heated from below by the planet's core. Just like the water, the hotter, lighter rock rises, and the cooler, denser rock near the surface sinks. This creates a slow, churning circular current. And I mean slow. This solid rock creeps along at about the same speed your fingernails grow, just a few centimeters per year. But over millions of years, this imperceptible movement is the engine that drives plate tectonics, reshaping the face of our planet. But this brings up a paradox. How can something solid flow? If you hit a rock with a hammer, it shatters. That's called brittle deformation. Deep within the Earth, however, under unimaginable pressure and scorching temperatures, rocks don't shatter. They undergo what's called ductile deformation. They stretch, fold, and flow without breaking. This happens on a microscopic level. One way is through something called dislocation creep, where tiny defects in the mineral crystals move, a bit like how a caterpillar moves by shifting its legs in a wave. This allows the whole rock to slowly deform. These mind-bending physics allow the solid mantle to behave like an incredibly thick, slow-moving fluid. Now, for a long time, this was a solid theory, but direct proof was elusive, and there was a 50-year-old mystery that puzzled geophysicists. Deep down, at the boundary between the mantle and the molten outer core, there's a region a few hundred kilometers thick called the D-double prime layer. Scientists noticed something strange here. Seismic waves from earthquakes, which they used to map the planet's interior, would inexplicably speed up as they passed through this layer. Why? Recent, groundbreaking research has finally cracked the case. A team led by Professor Murakami at ETH Zurich figured it out. They knew that the main mineral in the mantle, perovskite, transforms into a new mineral called post-perovskite under the extreme conditions in the D-double prime layer. But that alone didn't explain the speed boost. Using diamond anvil cells to simulate the crushing pressures near the core, they made an incredible discovery. They demonstrated that as the solid rock flows horizontally at this depth, it forces all the post-perovskite crystals to line up in the same direction. This uniform alignment creates a kind of seismic superhighway, a fast lane that seismic waves can zip through. For the first time, there was direct experimental proof. Solid rock flows deep inside the Earth. So what does this all mean for us up here on the surface? Everything. This subterranean river is the fundamental driver of almost all major geology. Upwelling currents of hot rock create volcanic hotspots like Hawaii. Where currents push continents apart, new ocean floor is born. Where they drag crust back down into the mantle, you get deep ocean trenches and powerful earthquakes. The collision of plates, pushed by this flow, crumples the crust to build massive mountain ranges like the Himalayas. Understanding this flow is even helping us figure out how quickly our planet is cooling. This new research suggests the Earth might be cooling faster than we previously thought. So the next time you stand on what feels like solid ground, remember the vast, hidden world in motion beneath you, an unseen river of rock, constantly and powerfully shaping the world we know. Thanks for tuning in to G Fun Facts Online.